Good morning class. In this segment, we will discuss about the next type of bonding, that is coordinate bonding. So we already discussed about ionic bonding, we discussed about covalent bonding, but in this segment we will discuss the third type of bonding, that is coordinate covalent bonding, or it is also called dative bonding. So we are going to discuss that point. So the next type of bonding is, it is called coordinate bonding, or it is also called coordinate covalent bonding, or it is also called dative bonding. It is also called dative bonding. So we have discussed this third type of bonding. So basically we are discussing about coordinate bonding. Now if you see, there is a word covalent over here, and we know that covalent is a word which is responsible for sharing of electrons. Yeah. So it creates one sense that in the overall mechanism of coordinate bonding, again we have to see sharing of electron. Just because here sharing will take place, that's why it is called coordinate covalent bonding. But there is a difference. Actually, the sharing of electrons takes place, but they are lone pair of electrons. They are lone pair of electrons which are going to be shared by the atom which is having lone pair, to the atom which is deficient in electrons. The second point is, lone pair of electrons are those electrons which do not take part in bonding. So lone pair of electrons are those electrons which do not take part in bonding, or they are not taking part in bonding. Just because they don't take part in bonding, so they are called lone pair of electrons. Just because they are called lone pair of electrons. So first we know 2 points about coordinate bonding. Just because we are saying coordinate covalent bonding means there is somewhere sharing of electrons, and because sharing of electrons takes place, so we are saying coordinate covalent bonding, or it is called coordinate bonding, or it is called dative bonding. So the first thing, the sharing of electrons which are taking place are lone pair of electrons. And the second thing, lone pair of electrons are those electrons which do not take part in bonding, or they are not involved in the process of bonding. Third part, we are going to explain what is coordinate bonding or what is dative bonding. So it is a type of covalent bond, but the difference is, in this type of process, both the electrons required for the formation of covalent bond is contributed by the same atom. So this is the most important difference between coordinate bonding and covalent bonding. In covalent bonding, we saw there is equal sharing of electron. If the first atom is sharing one electron, then the second atom will also share one electron. If the first atom is sharing two electrons, then the second one will also share two electrons. And if the third electron or the first electron is sharing three electrons, then the second atom will also share three electrons. But there is a difference here in coordinate bonding. In this type of bonding, a covalent bond will be formed. Rather, we should say a coordinate bond will be formed. But in this type of bonding, both the electrons which are required for the formation of covalent bond is contributed by the same atom. Means the two electrons which are required for the formation of a single covalent bond is contributed by the same atom. There is not equal sharing, but the two electrons which are required for the covalent bond formation is contributed by the same atom. And the fourth point is coordinate bond is represented by an arrow, and this arrowhead points towards the electron acceptor species, and the tail points towards the electron donor. Okay, so these are some major terms or major characteristics of coordinate bonding. First point is, in this process we have the main contribution of lone pair of electrons. The second thing, lone pair of electrons are those electrons which are not taking part in bonding. Third thing is, coordinate bond mainly differs from covalent bond in the fact that the two electrons which are responsible for the formation of covalent bond is contributed by a single atom or a single group, anything may be. And the fourth point is, coordinate bond is represented by arrow sign, where the arrowhead will point towards the electron acceptor, that is lone pair acceptor, and the arrow tail will point towards the electron donor, that is lone pair donor, one who is donating the lone pairs. So these are some of the major terms related to major significant, major characteristic features of coordinate bond. Now, next we will discuss about formation. We will see the formation of two examples of coordinate bond, that is formation of ammonium ion, that is NH4 plus ion, and formation of hydronium ion, that is H3O plus ion. So we will see two examples. So first we are going to see examples. So we will see two examples of this. First is ammonium ion, that is NH4 plus ion, and the second one is hydronium ion, that is H3O plus ion. So we have to see the two examples. We will discuss two examples of coordinate bonding. One is ammonium ion, that is NH4 plus ion, and the second one is hydronium ion, that is H3O plus ion. So as it is clear from the name itself, it is called ammonium because it is formed from ammonium. So this ammonium ion is called ammonium because it is formed from ammonia, that is NH3. And this is called hydronium ion because hydro is the word for water and it is formed from water, that is H2O. So we have to see actually the formation of ammonium from ammonia and the formation of hydronium from water by the involvement of lone pair of electrons. Actually ammonium, this NH3, this nitrogen has one lone pair over nitrogen atom, and this water has, oxygen atom has two lone pair electrons. So we will see the involvement of these lone pairs and we will see the formation of coordinate bonding. So now let us actually discuss the formation of the two products. The first one is formation of ammonium ion, that is NH4 plus ion. We will see the formation of ammonium ion, that is NH4 plus ion, which is our first example of coordinate bond. So in case of ammonia, we have two examples. So ammonia is formed from NH3. Ammonium is formed from ammonia, NH3. So the structure of ammonia is this. nitrogen atom has 5 electrons in its outermost shell, means 3 electrons are used in forming 3 covalent bonds, and still nitrogen atom has a lone pair of electrons. This 2 electrons are called lone pair of electrons, and this is ammonia molecule. Now, this has lone pair of electron. Now we will show approach of H plus ion. We will show approach of H plus ion. So basically our molecule was like this. And this was lone pair, and our H plus ion, our proton is approaching towards this molecule. Now what happens? This lone pair is coordinated to this H plus ion. So lone pair coordination. So this is our nitrogen molecule bonded to 3 hydrogen atoms, and when hydrogen ion approaches this, a coordinate bond is formed like this. A coordinate bond, the lone pair of electrons are contributed to this H plus ion, and this is our coordinate bond. This is our coordinate bond, and this positive charge redistributes itself over the entire molecule, and our final product is N single bond hydrogen, single bond hydrogen, single bond, and this coordinate bond, and this positive charge distributes itself over the entire molecule, and overall it gets positive charge, and this is our ammonium ion. So this is the formation of ammonium ion. In the formation of ammonium ion, we had our starting material ammonium molecule. Ammonia has a lone pair of electron. When a H plus ion approaches this molecule of ammonia, so this we saw the approach of H plus ion towards ammonia molecule. After that, the 2 electrons, the lone pair of electrons, are coordinated to this H plus ion. As a result, after this positive charge redistributes itself over the entire molecule and leads to the formation of ammonium ion. So this was the formation of ammonium ion. Next, we have to see the formation of hydronium ion, that is from water. Next is formation of hydronium ion. That is H3O plus ion. So it is formed from, we already discussed that it will be formed from water, H2O. So let us draw water. Actually water has a bent shape, but for sake of understanding we are making it linear molecule, we are treating it to be linear molecule. And the oxygen atom has 6 electrons in its outermost shell. So 2 are involved in forming 2 covalent bonds, and still it has 2 lone pair of electrons. So these are lone pair of electrons, and this is our water molecule. Now again we will do the same thing what we did for ammonium ion. Next is approach of H plus ion. We will see the approach of H plus ion. So this is oxygen atom, hydrogen, hydrogen. These are lone pair of electrons, and H plus ion is approaching towards this molecule. Now in this process we will show lone pair coordination. So this is our water molecule. This one lone pair coordinates with H plus ion, but still it has one lone pair, and still it has positive charge. So this is our coordinate bond. And finally, this positive charge distributes over the entire molecule and leads to the formation of HO, H, covalent bond H, and our entire positive charge. And this is the example of hydronium ion. So in this diagram we can see there is one more lone pair of electron over oxygen atom. So there will be a question arising that one more H plus ion can attack, but it is not possible, because if one more H plus ion will attack, then the compound will be H4O plus, which is unstable. So this lone pair will remain as it is, there will be no change, and the resultant product is called hydronium ion. So let us see once again what was the entire process of formation of ammonium ion. Now in case of ammonium ion, it is formed from, in case of hydronium ion, it is formed from water. So this is water molecule having two lone pair on oxygen atom. Now we are representing approach of H plus ion. When H plus ion is approaching towards this water molecule, after this H plus ion gets coordinated with this lone pair, one lone pair, but still one lone pair is present on oxygen atom. So this is coordinated to this H plus ion, and this is our coordinate bond, and this positive charge distributes itself over the entire molecule and leads to the formation of hydronium ion. The next lone pair which is present on oxygen atom will remain as it is, because if it be coordinated to next H plus ion, the molecule would be H4O double positive charge, which is highly unstable. So this was about coordinate bond. We saw two examples of hydronium ion and ammonium ion. So thank you guys.